This lesson is on vector space. Here we have 2 points, I, J, K, or X, Y, Z, same thing. So vector in space could be 3-dimensional, 4-dimensional, 5-dimensional, and so on. Okay, so here we'll just deal with 3-dimensional or 3D. So I, J, K, or X, Y, Z. So here's the first point, and here's the second point. We're trying to find the distance from point 1 to point 2. So very simple. The distance is always the square root. So make sure you take the second I, subtract from the first I. One more time. Take the second I, subtract from the first I, or second X, subtract from first X. Okay, so 4, subtract -1, but there's another negative, so make sure to put in parentheses. Second J, subtract first J, okay, and then second K, subtract first K. Okay, so negative gives me positive 1, 4 plus 1 gives me 5, so 5 squared is 25. -2, -3 gives me -5. Squared, so positive 25. 5 subtract 2 will be 3. Square 3 gives me 9. 25, 25, 50. 50 plus 9, square root 59. So the distance from this point to this point is square root 59. Now, what does this point and this point look like on the graph for 3-dimensional? Okay, so imagine that this is X, this is Y, and this is Z. Okay, so here's my graph, 3-dimensional graph. Okay, so here is X, so this side is positive, that side is negative. This is Y, so this is positive Y, negative Y. This is Z, so up is positive, down will be negative. Okay, so the first point is -1, 3, 2. So X is -1. So start at the origin. -1 go that way. So origin, -1 go that way. Positive go 1, 2, 3. Positive 2, which is Z, so go up 2. So there's my first point. Again, what I have here is just approximation, not exact graph. Okay. The next point is 4, -2, 5. So positive, so this way. So 1, 2, 3, 4. -2, 1, 2. And then positive 5. So 1, 2, 3, 4, 5. Okay. So from this point to this point, the distance is square root 59. Okay. That's what it looks like on the graph. Now we want to use the same point, but convert this into position vector. Okay, so take these 2 points, same points that we have, turn it into position vector. Okay, so position vector, all you have to do, again, same thing. Second I, subtract first I, that's here. Second J, subtract first J, that's here. Second K, subtract first K, that's here. And then I get 5, -5, and then positive 3. So 5I minus 5J plus 3K. So these 2 points turn this into a position vector. And if you remember, position vector always starts at 0, 0, which is the origin. So here in 3-dimensional, the origin will be here, and it will be 0, 0, 0. Okay, and our vector is 5, -5, 3. So this is I, J, K, or X, Y, Z. So 5 will be my X, so 1, 2, 3, 4, 5. -5, so 1, 2, 3, 4, 5. Positive 3, go up 3. 1, 2, 3. Okay, so from here to here is our vector 5, -5, 3. And if you do the magnitude of this, so here's the magnitude, 5 squared, -5 squared, 3 squared, which is also square root 59. So this is the position vector. This was the vector that is just floating in space. Okay, position vector is always from the origin out. Okay, and this is just the vector that's floating in space. So that's why we call it vector in space. Okay, so this vector and this are the same. It's just that this is at the 0, 0, 0, the origin. Okay, and this is where it is flowing in space. Okay, somewhere in the vector space. Here in this case, this is three-dimensional space. Okay, and as you can see, this distance and this distance are exactly the same, square root 59 and also square root 59. Okay, so this and this example, these two examples are for this graph. Okay, in three-dimensional. Okay, next we need to find vector in unit positions. Okay, so here's my vector 2, -3, 2i, -3j, -6k. So we want the unit vector. So first thing we need to do is find the magnitude. So 2 squared, -3 squared, -6 squared. So that gives me 4, 9, 36. Add them together, 49. Square root 49 is 7. So that's our magnitude. Again, magnitude is the length, the distance. To get the unit, you will take the vector, the original vector, divided by the magnitude. One more time. To get the unit vector, you will take the original vector divided by the magnitude. So here's the original vector. Here's the magnitude. 2 divided by 7, 3 divided by 7, 6 divided by 7. And don't forget the negatives. Okay. Now where is this on the graph? Okay. Where is this vector on the graph? This right here. Okay. So +2, so this is your x, this is your y, and this is your z. So +2, so here we go. 1, 2, because it's positive. -3, so 1, 2, 3. Okay, and then your z is positive, is -6, so go down 6. Go down 6, so somewhere over here. Again, what I have here is just approximate, not an exact. Okay. So the blue line is the original vector. The red line is the unit vector. Again, the unit vector is on the same direction, exactly the same direction as the original vector, but the only thing difference is that the unit vector is been shortened down, shrink down to unit. Okay, that's why it's called unit, shortened down to a unit. Okay, so this is the unit vector in red, original vector in blue. Same directions, unit vector gets shrink down to a unit. Okay, so this is what it looks like in three-dimensional. And I know it's a little bit difficult to see and visualize. Okay, again, what I have here is just approximation, not exact. Okay, next example. We want to find the angle between two vectors. Okay, angle between two vectors. So here's vector v, here's the vector w. So first thing we need to do is find the angle, do the dot product first. So 2 times 2 here, -3, 5, 6, -1. Okay, so when you do the dot product, I to I, j to j, k to k. Okay, just multiply 2 times 2, -3 times 5, 6 times -1, and always put plus in. Okay, so this gives me 4, this gives me -15, and this gives me -6. Add them together, my dot product is -17. Okay, now find the magnitude for v. So 2 squared, -3 squared, 6 squared. So that gives me square root 49, so 7. Find the magnitude of w. So 2 squared, 5 squared, -1 squared. That gives me square root 30. Okay. So this is our magnitude for v. This is the magnitude for w. Okay. So here's our formula, just like what we did to find the angle of between two vectors. So cos theta v dot w, v dot product w all over magnitude v times magnitude w. We have all these numbers, so we just plug them in. So the dot product of vw is negative 17. The magnitude of v is 7. The magnitude of square of w is square root 30. So put this in your calculator, should come out to be negative 0.443. Inverse cos over, make sure it is in degree mode. It is 116.3. Okay, so this vector, these two vectors, the angle between them is 116.3 degrees. Now where is that in the graph? So here we go. So here is our graph of this. Okay, the graph is this. Okay, so my vector v is 2, negative 3, 6. So x is 2, y is negative 3, z is positive 6. So 2, negative 3, 6. So 2. So here we go. This is 2. So x, y, z. So go over here, start at the origin, positive 2, which is here. And my y is negative 3. So 1, 2, 3. My z is positive 6. So just move up 6. Again, what I have here is just approximate. So that is vector v. Vector w, 2, 5, negative 1. So 2, 1, 2, positive 5. So 1, 2, 3, 4, 5. Negative 1, go down 1. So there's my w. So here's vector v, vector w in three-dimensional. And the angle between v and w is 116.3 degrees. Okay, so this is in three-dimensional. Okay, so this graph is over here. Okay, one more time. This graph is this. Okay, next, find the direction angle of a vector in 3 space. So here my vector, which is negative 3, I plus 2j minus 6k. So first thing we need to do is find the magnitude. So negative 3 squared, 2 squared, negative 6 squared. So negative 3 squared will be 9, 2 squared will be 4, negative 6 will be 36. So 9 plus 4 is 13, 13 plus 36, 49, square root 49, positive 7. Okay, so now we need to find the angle. So angle for alpha, angle for beta, angle for gamma. Okay, this little fancy y, this little y right here, that's gamma. Okay, so alpha, just consider alpha is your x or I, beta is y or j, gamma is for z or k. Okay, so to find because this is in three-dimensional, we need 3 angles from the x-axis, y-axis, and also the j-axis for this vector. Again, because we are in three-dimensional, we need the angle for x-axis, y-axis, z-axis to this vector. Okay, so it's very easy. All you have to do is negative 3 divided by 7, negative 3 divided by 7, which is here. Inverse cos, put that in your calculator, comes out to be 115.4 degrees. So that is the degree at the x-axis to this vector. Find the degree for y-axis. So positive 2 divided by 7, which is here. And then inverse cos comes out to be 73.4. So this is the angle that is angle for the y-axis to this vector. And then finally find the angle for gamma. So negative 6 divided by 7. Inverse cos gives me 149 degrees. So this angle is the z-axis to this vector. So again, this vector, because it's in 3D, you have 3 angles. The x angle from the angle from the x-axis to this vector, angle from the y-axis to this vector, angle from the z-axis to this vector. Okay, so where is this vector? Where is this vector on the graph? Okay, so here's my graph. So here's the graph. Okay, so -3. So x is -3, y is +2, z is -6. So -3 on x. So here's my x from the origin. 1, 2, 3. Okay, so it's negative. And y is positive. So go over 1, 2. Okay, so 1. So 1, 2, 3, because x is -3. Y is positive. So 1, 2. And then z is negative, so go down -6. 1, 2, 3, 4, 5, 6. So again, what I have here is just approximations. Okay, so this vector is right here in the blue line in 3-dimensional. Okay, and it is very difficult to see this because it's in 3-dimensional. So my x-axis, the angle from the x-axis to this vector is 115.4 degrees. So here's my x-axis. Okay, so from this x-axis, from this x-axis, because it's negative, from here to this vector in blue. So because this is negative, so from negative to here is 115.4 degrees. And my y, because it's positive, okay, because it's positive, so from this is positive right here, so from here to here would be 73.4. And my gamma my gamma is negative, so because it's right here, my z is negative, so 149 degrees. So here's the negative from here to here is 149 degrees. Now again, what I have here is in 3-dimensional. Now I know it's very difficult to see, and you probably say, well, wait a minute, from here to here, that's not 149 degrees. Technically it is, but it's just the way how it's drawn. This line is technically, this line right here, the blue line, which is the vector, this blue line is technically not in front of us, it should be in the back. Okay, so, and the reason it's in the back is because x is negative, y is positive, z is negative. So negative, positive, and down. So this line, just the way how it's graphed, this line looks toward, it feels like this vector right here, it feels like it's going forward to us, but technically it's not. This line is in the back. It should be somewhere over here. Okay, it should be somewhere over here. It's just that because the way how this is graphed, it feels like when you see it, it feels like it's forward, but technically this line, this vector, is in the back. It should be somewhere over here. Okay, so that's the that is the angle, 3 angles that belongs to this vector. So this angle from the x-axis to vector, y-axis to this vector, and z-axis to this vector. Again, this vector is right here, but according to this graph, the way how it's drawing, it looks like it's forward to us, okay, toward to us, but this line, this vector should be in the back. Okay, so that's the difficult part. So I hope you can imagine that. Okay, and the reason why it's in the back is because x is negative, so negative is this way, y is positive, so it should be this way. Okay, and z is negative because it's on this side, this square right here, this square right here, this should be in this locations, and then z is negative, so it goes down, so it should be faced that way, not this way. It's just that because the way how this is graphed, it looks like it's going this way. Okay, so be very careful. Again, it's a little bit difficult to see that and visualize that, but technically this vector is supposed to be in the back. Okay, because x is negative, y is positive, z is negative, so x negative, y positive, so positive is this way, and z is down. Okay, so that is the graph for that. Okay, so this example right here is for this graph. Okay, and then finally the last example is the same example that we did earlier. The same example. Okay, I'm using this right here. I'm using the same example, but I'm gonna write it as in this formula. Okay, again, same example, but I'm gonna use all of these informations and write it into this formula. Okay, so same example, but write it in this formula. So here's the same vector. We know what the magnitude is. We know the angle from the x-axis, angle from the y-axis, angle from the z. So alpha is your x, beta is your y, gamma, which is your z. Use the information, plug it into this formula. So 7 cos alpha, which is 115.4, cos beta 73.4, gamma, which is 149.0 degrees. And then since all three of these have the same magnitude, just factor it out, put it in the front, and that's what it looks like. Okay, so technically this example is just another way to write it in this formula. One more time. This example right here is the same thing as this, but just written in this formula. Okay, so one more time. This example is the same as this, but it is written in this formula. And this is how it looks like. So it is the same thing. So this and this is the same thing, just written differently. Okay, so that is for vector in space.